Hello and welcome to Cannon County High School Algebra 2. Yesterday we talked a little bit about probability, and we did an introduction to probability where we just calculated some really basic probabilities. Today is going to be another day where we're kind of doing a lot of review of things that you've done before, but that's okay because we're just getting into this and we need to make sure we have a good basis before we get to the more complicated things. So today we're going to be talking about the counting principle, and we're also going to be calculating some basic probabilities again. So Mr. Lyon, from what I understand, you're going to be able to take that mask off pretty soon, but not just yet, so I'm going to have you sit over there. And let's start out today with a story problem. Everybody loves story problems. All right, this one says, Billy owns 6 shirts. He's got a blue, a white, a green, a red, a yellow, and an orange shirt. And he owns 4 pairs of pants. He's got some jeans, some dress pants, some sweatpants, and some khakis. How many days could Billy go without wearing the same combination of clothes? Well, I know you probably can figure this one out in your head, but I'm going to do it by actually writing out the entire sample space. Excuse me. So let's do that. Let's start out and say, well, what if he just wore the jeans? If he wore the jeans, he could go 6 days because he could wear the jeans with the blue shirt and then the white shirt and then the green and the red and the yellow and the orange shirt. And then if he wanted to, he could switch to the dress pants, and he could wear the dress pants with the blue shirt, the white shirt, the green shirt, the red shirt, the yellow shirt, and the orange shirt. And then he could do the same thing with the sweatpants and the same thing with the khakis. So I've written out every possibility, the entire sample space, which is the hard way of doing this problem, but it's a good way to illustrate it. And now we could say, well, what is the size of this sample space? How many days could Billy go without wearing the same combination of clothes? Well, how many of these are there? There's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 4 times 6. Yeah, there are 24. And that's probably what you figured out without me having to write out the entire sample space. But if you take 6 shirts times 4 pairs of pants, you get 24 combinations. He could go 24 days without having to wear the same thing twice, the same combination. That is called the counting principle. And the counting principle is just a way to find the entire sample space. And the way you do it is you just multiply the number of choices to get the total number of possibilities. And we're going to do that on one of the IXLs. In fact, the 2 IXLs that we're going to do today, and we're going to do some of them right on the computer today, we're going to do CC2. Here's where we're going to be actually solving some basic probabilities, and CC3, where we're going to be using the counting principle to find the number of things in the sample space. So let's try. Here's the computer. This is CC2. And on CC2, we're just going to be finding some basic probabilities. This one says, the table gives a set of outcomes and their probabilities. Let A be the event that the outcome is less than or equal to 3. So on this one, there are 4 possible outcomes. Which of those outcomes are less than or equal to 3? Well, less than or equal, so the 3 is equal, 2 is less, and 1 is less. Notice that the probabilities all have to add up to how much? That's right, 1. They always have to add up to 1, and we learned that last time. But less than or equal to 3 means we'd have to add up all 3 of these probabilities, 0.2, 0.1, and 0.6. So the probability is 0.9 that it's less than or equal to 3. And that's really it. The only thing they can do now is maybe make it harder for you to add up the probabilities or ask the question in a strange way. But that's the idea. Let's try just a few more of these. Let A be the event the outcome is greater than or equal to 3. Well, greater than 3 is, 3 is equal to 3. There aren't any numbers that are greater than 3 on here, so it looks like it's just the same as if it were just the probability of 3, which is 0.5. Let's jump up a level and see if they can make these more difficult. Okay. The table gives a set of outcomes and their probabilities. Let A be the event that the outcome is a divisor of 1. What does that mean? Well, divisor is the number on top of a fraction. So a divisor of 1 just means which of these numbers could we divide 1 by that number and still get a whole number. Okay, so this, again, the only way they can make these difficult is by asking the question in a strange way. And this is really a vocabulary problem because divisor, again, means the number on top. So 1 divided by 1, that works because that gives you 1. What's 1 divided by 2? Well, that's a decimal, that's a fraction, that's a half. 1 divided by 3, 1 divided by 4, 1 divided by 1 is the only one that is actually a divisor of 1. So this one, they're asking for 0.25. The only one of these numbers that's a divisor of 1 is 1. Okay? How about this one? The table gives a set of outcomes and their probabilities. Let A be the event that the outcome is less than or equal to 1. Well, the only one that's equal is 1. There aren't any that are less than. So the probability is 0.03. Oops. Not 0.01, 0.03. There we go. All right, the outcome is less than 2. Well, there's only one number that's less than 2 in this case, and that's 1. If it said less than or equal to 2, well, we'd include the 2, but this one doesn't say that, so that's 0.23. Let's see if they can, let's go up another level and see if they can make these any more difficult. If not, we're going to skip to the next one. All right, the only thing they can do here is try to make it harder for us to add these up. Let's see, the outcome is divisible by 2. Well, divisible by 2, that means it's an even number. So we have the 2, the 4, the 6, and the 8. But look at these probabilities. All they're doing now is saying, well, I'm going to force you to use a calculator. So let's grab a calculator and let's see what we got here. 0.2 has a probability of 0.091 plus 4 has a probability of 0.092. 6 has a probability of 0.068, and 8 has a probability of 0.132. There we go. So I'm just going to add all those up on my calculator, and it says the answer is 0.383, and that's it. Okay, so that's CC2. So I want you to give that one a try. Now let's go ahead and try CC3. That's the one where we're doing the counting principle. Let's go down to CC3. And you'll see that these problems are kind of like the story problem that we started the video with. And they're just as easy because you're really just multiplying things together. Lisa is putting together a business outfit. There's 4 pairs, well, this sounds familiar. 4 pairs of pants, 2 dress shirts to choose from. For the jacket, Lisa has 7 options. How many different outfits can Lisa put together? Well, again, you could write out the entire sample space, but it really all just boils down to 4 times 2 times 7. And 4 times 2 is 8. 8 times 7 is 56. Okay? Now, why these are so easy? Why are we even bothering with them? Because you really have to have a good understanding of how to do this before we start actually calculating probabilities within these. We're going to be talking about dependent events, independent events, permutations, combinations. All of those things you're going to need, you're going to have a really good understanding of how to find the number of things in the sample space before you start. So Kenji is working at a hair salon and building a toolkit. There's 5 hair dryers, 8 straighteners to choose from. How many different kits can Kenji make that use 1 of each item? 5 times 8, 40. Let's jump up a level. Let's see, can they make these any more difficult? Eddie's family is going to install a custom swing set in the backyard. There's 6 kinds of swings, 4 kinds of slides. And the swing set has room for 1 of each. There are 2 styles of monkey bars available. How many different swing sets can Eddie's family buy? Well, 6 times 4 is 24. 24 times 2, 48. Let's jump up 1 more level, and that'll be it. Let's see what we can do here. At a local hardware store, Zach is selecting tools for a small tool kit, which will include 1 of each type of tool. There are 9 hammers and 3 screwdrivers to choose from. For the wrench, Zach has 2 options. Lastly, there are 5 possibilities for the saw. How many different tool kits can Zach build? Well, let's see. 9 times 3 is 27. 27 times 2 is 54. 54 times 5, I don't know, let's see. 54 times 5. That's 270. So yeah, you might have to bust out the calculator, but that's okay. You get the idea. Okay, so just try CC2 and CC3 just to make sure you've got it. This is not a real difficult one, but we'll get to some more challenging things later on where we're actually calculating some probabilities. All right, so thank you very much for watching, and tune in tomorrow and we'll see where we go from there. Thanks, bye.